Hello. Hopefully you can hear me. Hopefully I got everything set up properly. We're going to go ahead and continue reading The Cathedral and the Bazaar by Eric S. Raymond. Musings on Linux and Open Source by an Accidental Revolutionary. So last time we ended at the end of page 7. That might not sound like a lot, but with all my commentary, we weren't moving fast. So we're going to start at the page of top of page 8. Okay, so the rise of Unix. Far from the bright lights of the ARPANET, off in the wilds of New Jersey, something else had been going on since 1969 that would eventually overshadow the PDP-10 tradition. The year of ARPANET's birth was also the year that Bell Labs hacker named Ken Thompson invented Unix. By the way, the C programming language is also heavily associated with the Unix ecosystem. And here's the classic Kernighan and Ritchie. If you're looking for a good read and you like computer programming languages, this is a great classic to have around. Anyway, so Ken Thompson. A Bell Labs hacker named Ken Thompson invented Unix. And by the way, a lot of interesting things came out of Bell Labs. And Bell Labs, in case you weren't aware, so Alexander Graham Bell invented the telephone way, way, way back. And, for a while, Bell Telephone was the only telephone provider, service provider in essentially, certainly the United States, maybe the world, and that was just the case until they were eventually broken up as a monopoly sometime in the mid 20th century. Anyway, but they had a research laboratory going, and so a lot of the things that came out of Bell Labs you might hear about, and you might be like, well, what university was this Bell Lab associated with? Because they were doing all these, open greenfield research that didn't have any real. The things that you would expect universities to do, but Bell Labs, they invented, Unix. They, I think, I'm not sure exactly if the C programming language was associated with, but I do know that, that this guy, Bjarne Stroustrup, he invented the C++ programming language, and he of course he invented it when he was working for Bell Labs. So Bell Labs is, if you want to put it in those terms, kind of a big deal. Anyway. Let's see, where was I? Page, lost my place here. Okay. The year of ARPANET's birth was also the year that a Bell Labs hacker named Ken Thompson invented Unix. Thompson had been involved in the development work on a time-sharing OS called Multics, which shared common ancestry with ITS. Just to catch you up, time sharing basically means that you can have multiple users doing multiple things on one CPU, because the CPU runs so fast that you can divide up its time into little slices of computation, and you can have 10 people making a request to that computer or performing operations to that computer, and nobody's actually going to be able to tell the difference in speed just because the processor is so fast. And this was back in the 1960s. So we're talking, kilohertz, range in terms of speed. And so when you get up into the gigahertz range of modern CPUs, even in cell phones and that kind of stuff, there is a vast number of compute cycles that essentially aren't being used because there's just not a demand for it. There's just so much capacity on these chips to do work. And so that's what that's what Multics and ITS was. ITS was was, of course, if you'll remember from the last time, the MIT proprietary version of a time-sharing OS, whereas Multics was sort of a more not proprietary standard. It was used by a lot of other people. Anyway, and that's the idea: is you had multiple users and they could share the CPU. They could slice up the CPU time, and you could have 10 cycles and you could have 10 cycles, and then the first person go back to the first person, and that's what a time sharing time sharing OS does. Is it slices up the compute cycles into little bits that multiple users can share. Anyway, Multics was a testbed for some important ideas about how the complexity of an operating system could be hidden inside it, invisible to the user and even to most programmers. The idea was to make using Multics from the outside and programming for it much simpler so that the real work could get done. So even back then, the idea, this is 1969, I believe, so even then the idea was that, when computing machines, thinking machines were invented, they they're you have to they built in from the ground up, from transistors and so that kind of stuff, and so you have to spend a lot of time thinking about truth tables and what does it mean to calculate, and they're designing these things. But in 1969 we finally started getting into the era of, I have a problem, how do I design a solution? So they want to move away from trying to figure out how to configure the machine and how to tell the machine how to solve a problem. And that's what the computer programming languages and operating systems start to do for us, is that we don't need to know how the computer does what it does. We don't need to know how the computer comes to these conclusions, or how it makes a decision between two things. All we need to know is that it does, and we can use that then at a higher conceptual level to start solving problems. The idea was to make using Multics from the outside and programming for it much simpler so that more real work could get done. Bell Labs pulled out of this project when Multics displayed signs of bloating into an unusable white elephant. The system was later marketed commercially by Honeywell but never became a success. Ken Thompson missed the Multics environment and began to play at implementing a mixture of its ideas and some of his own on a scavenged DEC PDP-7. So you see the progression there. This project, apparently it just got more and more bloated, and but at the same time, this Ken Thompson character, he had a certain affection for certain features, and he wanted to have a system that would have those features, so he started building it. And oftentimes, these real innovations are started by just some dude who, just can't find a commercial application that does what they want, and so they just have to go out and make one. Um, let's see. Another hacker named Dennis Ritchie. Here we go. Another hacker named Dennis Ritchie invented a new language called C. See, Dennis Ritchie and Ritchie and Kernighan, called C for use under Thomson's embryonic Unix. Unlike Unix, C was designed to be pleasant, unconstraining, and flexible. Interest in these tools spread at Bell Labs, and they got a boost in 1971 when Thomas and Ritchie won a bid to produce what we'd now call an office automation system for internal use there. So, internal tools often turn into incredible, globe-spanning, impactful products. So, you always want to be, you want to devote and you want to prioritize your your money-making projects, but never be afraid to assign people to internal stuff, or give them incentive to work on internal tools, because if you do that, that's where some really interesting things might actually happen. But Thomas and Ritchie had their eye on a bigger prize. Traditionally, operating systems had been written in tight assembler to extract the absolute highest efficiency possible out of their host machines. Thomas and Ritchie were among the first to realize that hardware and compiler technology had become good enough that an entire operating system could be written in C, and by 1978, the whole environment had been successfully ported to several machines of different types. So that statement might, go by without really connecting, but the thing is that this was the first time Unix was the absolute first time, if I understand things correctly, where an operating system had been written in a higher level language. Previously, it had all been assembly language. Now we're getting into an operating system that has actually been designed from the top down, from the conceptual level down to the machine level, rather than from the machine level up to trying to turn switches and transistors into functionality. This had never been done before, and the implications were enormous. If Unix could present the same face, the same capabilities on machines of many different types, it could serve as a common software environment for all of them. No longer would users have to pay for complete new designs of software every time a machine went obsolete. Hackers could carry around software toolkits between different machines rather than having to reinvent the equivalents of fire and the wheel every time. And that's a huge deal. Where, if you have to, if you go from one machine to another, and you have to, teach it how to print something to the console, or teach it how to draw something on the screen. I mean, that's a lot of effort just to get some, user interaction, some feedback to the user. But now, since we have C, we have and we even have a standardized method of interacting with the computer in the form of this Unix operating system, we can start from the top down and say, I don't care what machine you're sitting in front of, you do this and it will do this. That was huge. And now computers become general purpose rather than, very specific and anyway. Besides portability, Unix and C had some other important strengths. Both were constructed from a keep it simple, stupid philosophy. A programmer could easily hold the entire logical structure of C in his head, unlike most other languages before or since, rather than needing to refer constantly to manuals Now that's an interesting point, especially because of the proliferation of complexity in our modern, tool sets. I mean, there is a real case for maintaining simplicity, if you want to actually build something complex. Because if you if you want to build something complex, it's often a good idea to have very simple components to put it together from. Whereas if you get into languages like that are trying to do way too much, and I hate to say it because I love C++. I think it was a wonderful thing, and it's done some real good in the world with, notwithstanding some of the elitism and that kind of stuff, which is, foolishness. And if you want to learn something, you can just ignore that. You might not be able to interact with the community too much, but just just pick it up and learn it. Start doing stuff. There's absolutely no harm in programming in C++ for your own enjoyment. And that doesn't make you a pedantic jerk, like a lot of the people in the community may be, or may project. But I would encourage learning it and trying it out, because it's a wonderful language. It's got all sorts of stuff. It's got so many different tools in there. And in fact, it's got so many different features that one could honestly argue that C++ is the standard reference implementation for basically any language concept you might come across. Argue with me if you want to, but it's got everything. And that's both wonderful, but it's also a huge problem because it's incredibly complex. And C, the progenitor of C++, C, it's not particularly complex. It's got very simple features that can be used to build incredible things. And a lot of the actual useful functionality you have to pull in precompiled libraries. Like you can't even interact with the console in C without bringing in a library, which is fine. I mean, those standard library routines are essentially just part of the language, but the point is that the definition of C itself is very, very simple. Other overly complicated languages, I would say Python is overly complicated. It's been around for a bunch of years now, and people have just tried to use it for everything, and they just use it for way too much, and it's just I think it was a great concept, perhaps in the beginning, but it's turned into this monstrosity that everybody thinks they should use for whatever they're doing, because it has this reputation of being simple. But the fact of the matter is, it's not. So many things have been added to it, and it's just it's a three-headed monstrosity at this point, is what it is. PHP is another one like that. It never had a formal language definition. It was just mishmashed and pieced together. I mean, it's very capable. It works well, and if you know anything about the history of PHP, I think the concept was great. I mean, it was invented by a guy who he needed something to help manage the server side of his personal website. That's why it's called PHP, personal homepage. I think the concept was great, but it was so useful that it was actually bought out by, basically the corporate world, and it was grown into this monstrosity, when honestly they should have been like, hey, that's a great concept. Let's go design something that will actually perform well in the environment that we want it in. And I don't misunderstand, PHP, it's been highly developed. It's been worked over and over and over, and it's fine. It just feels like, a monstrosity. That's why people complain about it. So, but on the simplicity side, things like ARM in comparison to x86, simplicity is a great thing, and it can really, help things. It can help you design things quickly. It can, help the processor run faster. It can reduce bloat. I mean, it introduces a lot of flexibility that you actually lose when you make things more and more complicated. Because if it's complicated, then you change one tiny little thing, and suddenly the whole thing blows up. But simplicity means that you can just put parts together, and you can produce really, really fascinating structures. Anyway, so I'm rambling, but that's kind of the point of this this whole deal. I'm going to try not to go past about 30 or 40 minutes here, but we'll see how it goes. Yeah, so we're on to the next page 9. So yeah, a programmer could easily hold the entire logical structure of C in his head, unlike most other languages before or since, rather than needing to refer constantly to manuals. And Unix was structured as a flexible toolkit of simple programs designed to combine with each other in useful ways. So Unix was designed from the ground up in that fashion. If you've ever used Linux or Unix, basically the operating system is fundamentally built on single function utilities. That's it. There's just a lot of them. There's just a bunch of these simple utilities, and they've been put together into a package such that you can interact with there's a kernel, don't misunderstand, but what you interact with as a user in a Unix or a Linux environment is just simple, one function, utilities. Unix and Linux are, you got a monolithic kernel, and actually I don't think Unix is monolithic, but let's just take Linux. Linux has a monolithic kernel, and you can make system calls to it, and on top of that, you just have this whole set of utilities for doing the things that you want. Yeah, and it's turned out to be incredibly flexible, and yeah. The combination proved to be adaptable to a very wide range of computing tasks, including many completely unanticipated by the designers. It spread, and that's an advantage of simplicity, is if you design a simple system that has, useful features, you never know what your end users are going to what they're going to do with it. So try to keep your functionality relatively simple, so that your users can build on it, because you want to keep it encapsulated. You don't want to add too much bloat to it, because you don't necessarily know where it's going to go. Okay. The combination proved to be adaptable to a very wide range of computing tasks, including many completely unanticipated by the designers. It spread very rapidly within AT&T, in spite of the lack of any formal support program for it. You make a good product, and people want to use it. It's really that simple. By 1980, it had spread to a large number of universities and research computing sites, and thousands of hackers considered it home. The workhorse machines of the early Unix culture were the PDP-11 and its descendant, the VAX. But because of Unix's portability, it ran essentially unaltered on a wider range of machines than one could find on the entire ARPANET. And nobody used assembler. C programs were readily portable among all these machines. So, you know, yeah. Unix even had its own networking of sorts, UUCP, low speed and unreliable, but cheap. So Unix was the first operating system that had networking out of the box. You could just buy it off the shelf and plug it into the ARPANET. Any two Unix machines could exchange point-to-point electronic mail over ordinary phone lines. This capability was built into the system, not an optional extra. In 1980, the first use, so, you didn't have to pay extra, for having the capability to exchange email. This was world-changing at the time. In 1980, the first Usenet sites began exchanging broadcast news, forming a gigantic distributed bulletin board that would quickly grow bigger than the ARPANET. Unix sites began to form a network nation on their own. So these Unix machines are why, are how the internet escaped the ARPANET and grew to be something bigger. Unix sites began to form a network nation of their own around Usenet. A few Unix sites were on the ARPANET themselves. The PDP-10 and Unix Usenet cultures began to meet and mingle at the edges. But they did not mix very well at first. The PDP-10 hackers tended to consider, and this is always seems to be the progression, the PDP-10 hackers tended to consider the Unix crowd a bunch of upstarts, using tools that looked ridiculously primitive when set against the Baroque, lovely complexities of Lisp and ITS. Stone knives and bearskins, they muttered. So, I am not going to sit here and say that just because something's new means it's better. That's fundamentally not true. And if something's old, that doesn't mean it's worse. I mean, Lisp and ITS were wonderful things in their own right. But Unix and C and the broader internet that those things introduced were also wonderful things in their own right. And, it's okay. It's okay that things change. It's okay, And there was yet a third current flowing. The first personal computer had been marketed in 1975. Apple was founded in 1977, and now we introduce Apple. And advances came with almost unbelievable rapidity in the years that followed. The potential of microcomputers was clear and attracted yet another generation of bright young hackers. Their language was basic, so primitive that PDP-10 artisans and Unix aficionados considered it beneath contempt. So just imagine that. You have MIT with the incompatible time-sharing system operating system. You have Multics, the alternative to that other places were using. So ITS and Lisp came out of MIT, and then you have Multics, derived, started with Multics, Unix was derived from that, and C was the language of that ecosystem. And then you have suddenly coming on the scene here, we have the home computer, the Apple I. There were a few others as well. The Commodore 64, that's arguably, even more popular, but yeah, the Commodore 64, for whatever reasons, never really evolved into anything terribly much beyond it. It certainly did influence the later era, but the 6502 processor, is sort of a different beast than the x86s that came out of Intel, um, and such. Now the Apple One, of course, it was working on a 6502, but Apple then proceeded on to I think they made their own processor or something like that. I'm not really big into the history of Apple, but my point is that the Commodore 64, although extremely popular in the home computer market, the company Commodore, it just kind of disappeared, whereas Apple has continued on to this day, and that explains a lot of the subsequent influence of it. If Commodore had not died, or whatever it is that happened to it, you know, the home computing landscape would probably be significantly different than it's turned out to be. In any case, so you got those three camps, and they're not exactly competing, but you got two branches of the academic world, in the mainframe computer geeks with ITS and Lisp and Unix and C, and then you have the home computer industry with Apple and Commodores, and he's not mentioning Commodores, but it I think it was bigger at the time than a lot of us may remember. Anyway, so that's the context within which well, maybe it's good to point out that the fundamental thesis he's working on here is the difference between open source software development and closed source proprietary software development, so he's not quite done with it, and I'm not going to continue on because I guess I like to talk too much. But in any case, this is the historical context within which the computing viewpoints of just to give you people to hang on as a framework. You got Microsoft with their closed source model, where we own it, you have to pay us for it, versus the I'm a hobbyist, I like to build things, and you can use it for free, and if you can improve it, that's good for all of us. And so that's the historical context where this question of which style of software development is best started growing out of. So the next section that we'll read next time is the end of Elder Days, where he's going to be starting to talk about how we're moving away from the universities, I think, and into independent software development. I mean, some of these guys who were involved in the open source movement, like Richard Stallman, I believe he was at MIT. They started out as university guys, but Linus, what's his name? The Linux guy. I'm sorry, his name is escaping me just at the moment. But he was just a guy from Finland, and I don't think he was associated with any kind of university, and he just decided he wanted to build himself an operating system kernel. And as a side note, you might actually notice that trying to build your own operating system from the ground up is kind of relatively popular in certain circles right now. Linus Torvalds, that's his name. And I think that's probably because a lot of young people have ambitions and they want to be like Linus Torvalds, and but realistically, you're probably not going to be building your own operating system from the ground up to the same measure of success. And also, it's worth pointing out that neither did he, right? So Linux was actually, he found basically an abandoned project, I think, called Minix, mini Unix, and he got the source code from it. I don't really know the story too well, but basically he got the source code from it and he started modifying it, and eventually all of the parts of Minix were subsumed by new code, but he didn't start he didn't start his own project from the ground up. He took somebody else's and started modifying it. Anyway, so there you go. Like I said, next time we'll get into the end of Elder Days and this sort of move into the next generation of computer geekery and development styles and the collaboration that the internet could provide that simply was not available in earlier eras. All right, thank you for joining me. Have a nice day.